Aluminum block for the foot pan is set on top of here. I have to make another and cut out another piece to carve into it to make a wall lining maze. So the maze that I'm going to do is a swirl. I'm going to cut within the metric range, within the width, 3 millimeters thick, to make the cutout of the maze round and to swirl around the metric range, around towards the center. And just cut alongside. After I cut out the shape, I'm going to cut alongside millimeters from the edge and just knock out the center piece on top to close it in. That would be like my microfluid chamber. The repulsive force to the wall exterior. However, I'm going to cover the nickel-neodymium magnets with epoxy resin, crystalline. Have to be very thin to swirl around the ultracapacitor enclosure, joined together, separated by wax paper, the cathode and one for the anode of the aluminum foil ultracapacitors. Then I'm going to add a winding coil around it so I can synchronize the ultracapacitor with the magnetic field through the nickel-neodymium being alongside to the induction. Then I have to use a magnetic sensor, which is magnetic sensory. It actually is a magnetic flux density sensor, and it would compress the magneto sensed and transfer current to synchronize, actually AC, and transport it to the magnetic sensor AC, and the AC to the rectifier, and the AC current will flow through the magnetic sensor. The magnetic sensor will go through the rectifier, and the rectifier will bus the output current of the DC current to the winding coil, back and forth. I will use also a switch, cutoff switch, that is going to allow it to constantly go up and down like a motor. So I would have to wrap the coil line back and forth over the ultracapacitor. However, the aluminum, then I must bond the aluminum into the alongside where the nickel-neodymium is localized. I have to cover the winding coil with epoxy crystalline resin so that the housing, the oxygen, the wiring are not exposed to the oxygen. Before I apply the nickel-neodymium, I must apply the piezo buzzers, and I would have to put them behind it so I can vibrate it to cause the magnetic field to broaden outwardly. Once I transduce it on all sides of the swirl, it should force the electrostatic out of the chamber. Now, around the aluminum is still grounded to here. It will still force it to go up. So it's like self-levitating ion block. Okay, so I gotta mount these in a permanent state and fill this with putty so that it would not come out. Here I have to do the same thing so that it would not come out. Therefore, I would have to turn it inside here so that the magnetic force will be moving in a linear motion and downward. So the magnetic winding will wind towards the magnet and cause the magnet to move forward, upward. So the magnetic repulsive force, the winding shall escape from the magnet and the aluminum and cause the aluminum to go up in the air. And as long as I keep it in sonics, it will constantly move up and up and up and up and up. Hopefully, that's what I'm planning to try and to test to see, hopefully, that I get it to rise upward instead of turning upside down. Now, I'm going to try to use a magnetic winding for a gyroscope so I can keep it moving upward in a linear motion. And that's going to be the next part that I add to it. Goodbye.